My name is Avik Sengupta. I came across Julia, I think, in 2012 when Viral leaked the blog on Hacker News. Famously, candidate. So I have my Julia directory on my laptop. This current laptop has been active since then, rebuilding quite often. I have been a Java programmer for the last 15 years, and therefore I essentially look at other languages to keep me sane. For a while, Ruby was my go-to language for that purpose. I spent many happy hours writing Ruby, and for the last 2 years it's been Julia, and I have not written any Ruby for the last 2 years. So that's my origin story. This talk is really about what happens when you use Julia in a commercial application. You use it in a team where, unlike everybody here, they are using Julia because their bosses told them to, as opposed to having found it themselves or compiled it themselves. So it's also something that clients depend on and needs to run every day. So this talk is really a sort of stream of consciousness about the things that we've gone through in writing this application over the last few months. Right. So this is what Julia produces. It's our company does financial research. It writes reports for brokers. Most historically, they have all been written manually, and my role is to essentially automate the production of some of these reports. So the first one that we've managed to completely automate end-to-end is quite simple. It's a technical analysis report on end-of-day prices for stocks of exchange prices. It figures out, it calculates a few hundred indicators, does some machine learning to figure out which ones are significant, draws a chart, and writes a report. So essentially, there are a few parts to it. There's a core numeric part, which is probably the biggest part of the code by volume. It, as I said, calculates a few hundred indicators, things like moving averages, RSIs, many more exotic stuff. It then generates a recommendation using decision trees to say that it's looking up, trending down. Once the indicators have been calculated and the recommendation generated, we need to then plot it, nice little charts. We then generate the sentences that talk about that chart, so about 4 or 5 sentences that talk about the recommendation, talk about the market, describe what the chart is showing. And finally, it's all put together in a nice little PDF with the layouts. And of course, since this being a financial application with a long disclaimer at the end, it's important to don't forget the disclaimer. The reason the disclaimer is important is that it needs to be laid out properly, paginated properly with the disclaimer. So all that needs to be stitched together into a PDF application, into a PDF and potentially into an HTML for some policy use. So that's what sort of the background to the application that we developed. So the first question obviously is why Julia, and I think my personal answer is why not, but I think we need to explain a little more to most other people. The key idea came from, the key sort of reason for using Julia is that this work, the algorithms that we use have been developed by quantitative analysts within our company, who historically, like most quantitative analysts in finance, use MATLAB to generate these algorithms, so calculate the indicators and do machine learning on top of that. Now, using MATLAB is fine for creating the models, but obviously you cannot deploy MATLAB at all, and believe me, I've tried. We tried deploying to Octave, which obviously was a whole other kettle of fish. But even deploying MATLAB itself to a production server, running somewhere externally, is a huge, huge pain. We ended up writing, sort of PowerShell scripts that start MATLAB. So one of my key ideas was that the code that an analyst writes, that a quantitative analyst writes, should be the same code that goes to production. And in the financial industry in general, there are legions of programmers who made a living in the last 50 years converting Excel code to Java or R code to Java or MATLAB code to C++ and so on and so forth. So I wanted to get away from that. As a startup, we can't afford to do that. It's too expensive. The other thing is that currently, as I said, we do this end of day. Eventually, we want to do it on 5-minute or 10-minute data, so it needs to be fast at some point. Although speed was not a current requirement, we want it to be fast in the next 3-4 months. We want to do it more real time, so it needed to be fast. So hence, that was another reason to choose Julia as opposed to doing it in Python, which was another option. So, and finally, of course, somebody has to try out Julia in these sort of environments. So I thought, I can get a talk out of it. The team, we are 3 developers. They are all remote, so they're in 3 different cities in the world. And we spent the last 3 to 4 months since about from the beginning of the year. Started this. Out of the team, other than me, there's, I said, one quant who was a MATLAB developer originally and one Java developer. In terms of working with the team, Julia syntaxes has never been a problem with anybody. The biggest issue was teaching a MATLAB programmer real programming practices. The Java developer picked up Julia very well, and all the sort of numeric stuff which a Java programmer is really exposed to. Julia is good at it intrinsically, so you don't have to worry about a lot of that. So the Java programmers move to Julia was much easier for me than a MATLAB programmer moved to Julia, surprisingly. But,
did the MATLAB programmer even realize that there was something to learn?
Once he was told, yes, but not intrinsically. Right? So there was a lot of effort in coaching about it. So I asked my team, what do you like about Julia before this talk? And the MATLAB guy says one of the things I like about Julia is that you can have more than one function in a file.
Don't laugh.
It was a big revelation.
The semicolons.
Well,
a lot of thought went to that feature, I guess.
So surprisingly, getting a MATLAB developer to use Julia in production has been more difficult than getting a Java developer to use Julia in production. Anyway, moving on. So the packages that we use, and obviously datetime, which is now dates, but we still are on datetime. ODBC is interesting, and I want to talk a little bit about ODBC because every time I talk to people who want to use Julia in a sort of more commercial environment, say how does it interact with databases? So I say ODBC, and the reaction is ODBC. Who uses ODBC? It's like one thing that Microsoft created 25 years ago, and the last time I used ODBC was in Windows 3.1. Never touched ODBC after that. However, again, surprisingly to me as well, the ODBC.jl package is really nice. It works well. It hasn't crashed. It's fast enough. It connects to every kind of databases that you want. It works on Unix. It's not on Windows. It works very well on both Linux and Mac. We develop on Mac and deploy on Linux. It's surprising, but it's true. ODBC works well, and when I started this, that was one of my biggest concerns of how to interact with the database. But ODBC does it well. And 6 months ago, if you would have asked me what is my biggest hope for a package in Julia, it would be a MySQL driver or a PostgreSQL driver. But now I'm fine with ODBC, and I don't care about native drivers for the language. So that's great. We use the decision tree package by Ben Sadeghi. He's here. Again, that's a pretty cool package. It's very easy to get started with. Pretty fast. Takes a while for training, but once you've trained it, it's very fast. Get most decision tree. Again, no issues with that. And of course, Gadfly, and we'll talk about Gadfly a little more later as well. But we use Gadfly for all the charting, so the charts that you see are we call out to Java for a couple of things which Julia doesn't do natively yet. One is we use a natural language generation package called Simple NLG, which helps us string together sentences. And we go out to Java for that. The second thing is the actual PDF generation. I think somebody's written a Julia package wrapping some PDF generation libraries, but we use not just PDF generation, but also the layouts. So things like the headers there and the footers there, paginated properly. So we use a package called FOP, which is a Java package, Apache package that does all of that, and we call out to Java. In fact, I have an unregistered Julia package that does that. So one of the main reasons why I did JuliaCon was to call out, which is the best thing out there for some objects. So that's the sort of subset of packages. It's not a lot, out of the 350 packages that we have. I've sort of used in Angular in 3 or 4 of them. And, but all of these, again, stable and never crashed in production. Right. So I think in 2014, if you're looking at using Julia in Angular, the biggest decision that you need to take is whether to use stable or nightly or source. And that will define your workflow for the next 6 months of your project. So it's important to take that decision with your eyes open. So now one of the issues here is that I read the Julia dev many list, and I have source build on my machine, so I keep track of all the commits that happen. But obviously, the rest of my team doesn't need to and doesn't want to, shouldn't as well. So initially, we started with using stable. So we started writing the code in using Julia stable, which is the point for the last few months, and that was fine for a few months, but very soon we found that packages started, not depending on 0.2 anymore. And about halfway through the project, we sort of took a call that it's becoming too much of an effort in keeping up with packages that break 0.2. So we decided to move to 0.3, and what we've done is sort of take snapshots once a month. We try and take snapshots of a week ago, so that we have been committed in the last few weeks that break things. So I sort of track the packages at a point where it looks relatively stable and no major PRs have been checked in. We take a snapshot and then everybody uses that snapshot. So that's our workflow at the moment. But as I said, if you're using Julia in real life, then that's an important decision to take. A similar decision is about packages, right? So when you're developing some code in Julia, at what point do you do a package dot update? And initially we thought that we would sort of stick to a known good snapshot, but packages move much faster. In fact, packages move much faster than Julia base. And in particular, Gadfly, all the goodies coming in Gadfly we want to miss out on. So we've ended up doing package update quite often. We typically will the team do a package update at least once a week, if not quicker. One of the issues is package update in Julia is an all or nothing thing, right? So you update all packages that are there that are in your environment or that you have installed and added. At some times, I've thought that it would be good to have sort of a preview update of some sort. You update your metadata, and then you see what will update if I run a package update. and then sort of take a call, maybe look at the change logs of those packages that are going to be updated. So a little more a granular way of doing a package update would be useful. Good. So my trip here has been worthwhile. So that's the other thing. As I said before, is packages removing backward compatibility with Julia 0.2. That's one of the biggest issues that we faced when we were developing this code. And so I think one of the most useful things that I have done within the Julia ecosystem is add Travis configs of various packages, including Gadfly, to test with 0.2. I think my message for all package developers here is please keep compatibility with the last release version. 0.2 at this point is water down the bridge. I don't think we are getting back there very soon. But once 0.3 comes out, I would hope that all packages support 0.3 for much longer than packages supported 0.2. So in the 0.4 cycle, it would be really nice if all packages supported 0.3 for the foreseeable future. So if there's one message that I want to give all package developers out here,
what's more important, to not break the previous release or to provide new goodies to the previous release, right? I mean, one option is to just simply, fork a branch for the previous day release and don't touch it, and then you won't break it.
So that is sort of, at the very least, do that. Right? But the thing is that for things like Gadfly, right?
Yeah.
There are new goodies coming every week. And I really don't want to miss out on that. Right? And I keep saying Gadfly because that's probably our biggest dependency. On the other, so one thing is, in terms of Gadfly goodies, yes, I want the Gadfly goodies, and I'm willing to take a little bit of pain for that. The trouble is, Gadfly depends on almost everything else. For good reason. In fact, Gadfly is probably the best test case of the Julia ecosystem that is there currently. So I want Gadfly goodies, and I'm willing to take a little bit of pain for it. But when I upgrade Gadfly, I upgrade distributions, I upgrade data frames, then I upgrade numeric extensions, everything beyond that. And that gets to be a little bit of a pain. So yes, at the very least, keep a backward compatible package, don't touch it. But things move and packages move, so it'll be nice if some people are the last release version can use those goodies. So of course, using Julia, which is a 2-year language with 18-month-old packaging ecosystem, there are going to be bugs. So the one single message that I have for dealing with those bugs is to create minimal test cases. I think that's, to me, the success of that bug getting fixed is directly proportional to the quality of the test case. Again, going back to Gadfly, Daniel has fixed lots of our bugs. Thank you. And any bug that has not been fixed has been because we didn't put enough effort into a minimal test case. So that's like the one biggest thing when you're when you're working in an ecosystem like this. And I think it's more than Julia. If you're working with any open source project, creating good test cases is the best way you can get support from an open source ecosystem. So that's probably that. Guess everybody will. Right. Using stuff in production, obviously we need to be logging, and in Julia there are currently 2 logging tools. The original logging.jl, which we currently use, and it's nice and simple, and it doesn't do much. It just logs stuff to a single location, which is good enough. At the very least, you need that rather than system out. System out printer is the worst thing that anybody knows. Kevin's logging.jl, simple works. There's a lumberjack by the Fourier guys, which is a little more full-featured. It has stuff like pluggable loggers and those sort of goodies. that you would expect if you have used something like Log4j or Log4j. And I'm hoping at some point they'll get merged and there'll be one good logging framework rather than having two, which I'm sure confuses people. We started using logging.jl before Lumberjack was created, but if I start a new project, I would probably use Lumberjack. As I said, it has a little, it is a little more sophisticated. Although I think a boring thing like logging, whether it needs a funky name like the Lumberjack is up for debate. Testing. Of course you should be testing. And there are quite a few options. Unfortunately, because there are so many options, we've just gone with base.test because who wants to see which one of this is good. And I'm sure some of them are much better than base.test. But the problem with so many, it's good to have a diversity, but the problem is with so many is that you will need to invest a lot of time in figuring out which one you want to use. They are not all replaceable. Some of them are. So quick check is a slightly different take. Fixtures is something that builds on run test to create data fixtures. I think the last few ones are not in metadata yet.
Yeah, I abandoned my projects. I use FactCheck.
Okay, so
from my observations, FactCheck is the most popular one. It's like I've seen it across the most packages, and I've looked at a lot of packages.
Yeah, that's still that number. If you could get that number.
Yeah, I might get a little bit tonight.
Okay, good. So that's good to know. So maybe we should all be using FactCheck. But no, testing again is very opinionated, right? So people like to test in different ways. So it's good that there is diversity, and I think sometimes diversity does get you to a place where you're analyzing things too much. But anyway, so we use base.test. We use sort of custom test runners to run the tests. But base.test is fine for most users. In terms of deployment, so talk a little bit about deployment. The way we deploy stuff right now is on Amazon. Our servers run on AWS. And so we've created a custom AWS image with a known good Julia Batley. We use Ubuntu images, so we use the pre-built Ubuntu. We don't have to build the Julia on AWS images. And that works reasonably well. You might be leaving some performance on the table because of using the pre-built package. It's not a great concern right now. So we've created an AWS image that we run on as many instances as we want. The image itself contains Julia and all the packages that our project requires. So we install it, Julia, do package.add, and then snapshot that image, use that image to start the AWS instance. The code itself, our project itself is deployed using Git, using Amazon Hooks. So that part works well. The trouble with this deployment strategy is that it works fine for hosted systems, and it works fine when you have one project on one machine. There are two problems. One is that if you have different projects on the same machine, or two different services running on the same machine with different dependencies, then you have to basically create a union. And then if your dependency diverge, then that gets to be a problem, especially with versions. The second thing is that we have some situations in our company where we have done Julia work for clients, where written some machine learning code for Julia for clients, and we ship the Julia code to them. But we then have to tell them to package install a certain set of packages. In fact, for this client, we created an AWS image for them and told them to run that code in that Amazon instance. So one thing that I hope will happen at some point is something like a bundler for Julia. I put a question mark because the idea of a bundler in Ruby is very well established, but it's also very controversial. When bundler was announced in the Ruby community, there was a huge amount of controversy. I don't know why, but people came to blows on whether you should use pure Ruby gems or use bundler on top of Ruby gems.
What is bundler?
Bundler is just a text file where you say what your dependencies are, and you say bundle install, and it will sort of
Specific version?
specific versions. So it's a wrapper around Ruby gems, essentially.
And it does like directory local for your
It'll do it.
project, right? Like it's isolating the dependencies. Like
So it'll do it
it's like
within your
virtual.
project directory. So you put a bundle file in your project, and it will create it within
I've
your
always
project.
found it very painful. Like whenever I do something with Ruby, it's like which version of my gems is it using? Like the one that it somehow magically installed. with
So
somewhere.
bundler is meant to fix that.
Yeah, it's meant to fix it, but it makes it much worse.
Don't say that out loud in a RubyConf. So for some reason, bundler is very controversial in Ruby land, but the Rails community it certainly has standardized on bundler, and everybody uses bundler. So something like that for Julia, where I can say that here's my code, and it works with these versions of packages. Put it all together in one zip file or whatever. Whatever the actual transfer mechanism can be anything, but something that can package it all together.
Yeah, require file?
Yeah. Have you tried at all checking Git packages into Git as submodules?
No, I haven't. I'm just scared to do that.
Don't.
Just checking.
So, so when package started, one of the ideas was that the metadata, right? Metadata itself doesn't.
That didn't work out.
That didn't work out. I'm scared to go there.
I have actually been doing that, and I've gotten it kind of working, but it's kind of a nightmare. It's mostly the fault of Git submodules being horrible. If Git submodules were not horribly broken, then Git pag they are.
So yeah, so as I said, right now we bundle by creating an AWS image and running that. That's our bundle. More granular way of doing bundling. At some point we'll do this. The next question is stability, and the answer is crawl. If we restart the process every morning, we will crawl. But we do that just to touch wood and not tempt the devil. I've run this code for a week, without starting. It's not crashing. So the code itself is quite simple. We are not doing anything out of the ordinary. And so, as I said, we don't have memory leaks. It runs fine for a week, but just to be on the safe side, we don't want people shouting at us. When the reports will go out, we have a cron job that restarts it every morning. That's fine. So no stability issues. Stability is, in many ways, it's a bit of a trust question, because people won't trust it unless they run it themselves. They'll say, oh, it's a new language, it's stable enough, blah, blah, blah. Restart it every day, and that's fine. And I say that because lots of people talk about Java as this sort of prototypical enterprise language, and the majority of the Java teams that I've worked with actually restart their Java services once a day, just to get safe side. So there's nothing wrong with not worrying about stability too much. One of the last things I wanted to talk about is, might be controversial to this audience, which is that there's this idea of a publication quality chart, or a publication quality graph. And unfortunately, the kind of charts that you would put in an academic paper is very different from something that I can put that goes out to a financial analyst. Right? An academic chart is much denser in information, and the kind of charts that I'm drawing with technical analysis has probably 2 or 3 ranges, and that's about it. And it has to be much sparser. It also has to look much nicer than a chart or a graph in a paper. For example, the lines have to be thinner. Charts in academic papers always have 2 thick lines for some reason. I don't know. So I think a lot of I've used R previously, and a lot of charts created with R. You have to do a lot of work to aesthetically manage the look. So to make the lines thinner, to make the colors more muted, use pastel colors rather than garish colors, and so on and so forth. And again, the aesthetic that Gadfly, the default aesthetics of Gadfly works very well, and like that. And so we had to do very little work to style the Gadfly charts ourselves. So a little bit of color changes is all that we need. I think the prettiness of Gadfly graphs worked pretty well for us. Right? Finally, I asked my team, their wishes for Julia, and top of the list was a visual debugger. That'll really make a difference in terms of productivity. The current debugger is pretty good. The trouble is you have to go into the source and add a line and save it and do that. So if you can click next on visual debugger, that would be much nicer. Just in terms of interacting with the VM while you're debugging. Easier binary dependencies. That's still we used HDF5 in one of our projects, and we've been installing HDF5 in Windows. So that's something that I don't know whether there are easy answers to it. And the other complaint was general package documentation. I'm sure everybody knows that that's an area that we need to
There's a very easy solution to that. Don't use Windows.
Actually,
I know that follows that.
no, out of my, so we said we were 3 developers. One of my developers has already moved from Windows to Linux. So the other guy is in the process.
But I mean, even on Linux, it's not as if binary dependencies are a complete non-issue. So.
Actually, honestly, I think right now, I found that the Mac is probably one of the worst in terms of binary dependencies right now. Yes, because homebrew and the pre-built homebrew stuff is very specific to versions of Mac and doesn't work on 10. So it works on 10.8, it doesn't work on 10.7 and 10.9. And then there are things about the homebrew.jl has its own repository, its own local disk where it stores the binaries. But if you have installed some packages in your global homebrew and packages in your local homebrew, then it gets confused. It's not really homebrew's fault, it's the whole Cairo and GTK and the whole dependencies of that. Thankfully, in Gadfly these days, Cairo is optional, so that makes so much easier. So finally, it can be done. It's not as risky as it sounds, but obviously, it's not as easy as it's not as easy a decision as trying to do it in Java. For me personally, the benefits certainly far outweigh the downsides. So I'm all for it. Thank you.
Okay, I want to take questions.
You brought up a bunch of really good things to talk about, so thanks for going through all of them. So the first one that I remember sticking out, we were talking about maintaining backward compatibility to old versions. And so yeah, so like forking off a branch and just like leaving it alone is one way to go. If you do want to continue to work on your package and be able to kind of maintain compatibility with both versions, like, do we have good tooling to kind of make that process easier?
Package validator.
Well, so that's definitely one huge awesome step that Ian's been doing to make sure that we can tell when these things break. But also, like, I know we have there's like the @OS10 macro that you can kind of wrap things in so that it only happens on OS 10. If you want to have like your same build run with 2 different versions, but you have to, so that you don't want to have one code base, but you have to do some things a little bit differently with O2 and O3. Do we have like an @0.2 that you can do, or
we use if statements to jump.
How does it work again?
It's just like we're doing it a couple places where we need it, so it's not a big deal for us. But yeah, we just use like a global constant. I think that's like the version. But like, I think a better practice beginning, people thinking about like releases, like we release a version and we like create a branch and get like then there, tag it, and then you like make it clear cut. The whole semantic versioning thing is kind of not used pretty loosely. I think that it's probably used better for the Julia community than some other communities, but it could get better. It's just a matter of like
being careful, you know. And little things screw people up all the time, like test throws got changed to take 2 arguments, and people didn't even say like downloaded a new nightly, and they're like, oh, test throws isn't working, or I'm going to change it. But test throws didn't change to 0.2, and now these tests are failing while the code still works. And I don't know, like. So, like, for example, a jump, there's no way around it. You're not going to like write 2 different versions of test files. You do that with the warnings on 0.3.
You can define a compatibility macro for test throws.
That's a good idea. But yeah, it gets messy. But branching, like lots of branching.
I wonder if it would make sense to support running the tests of 2 different versions of Julia automatically when you run the tests for your package.
A lot of packages are doing that.
Travis, you can do that, right?
Travis, yeah, people are doing that.
The default
you can
Travis
install
template-
Julia deps, Julia nightlies, and Julia releases as separate.
So our default Travis, the skeleton Travis that we have currently already has that. So a lot of packages do that. So you can run both 0.2 and 0.3.
So that will happen
That's very
automatically if you run the tests for your package?
Not on the local machine, but on Travis.
Well, maybe we can make that work on a local machine too.
But then you need to maintain 2 different things on your own local machine, which is...
Who doesn't have that?
I have not a single working one.
So who's writing virtual and for?
Probably me.
I actually wanted to give a shout out to Jens pkg.julialang.org.
Yeah, bravo. That is bravo.
A lot of what we are talking about, that's the solution. So that's great. Any more questions?
So what would you feel like so how Conda, I don't know if you're aware of like the scientific Python community, but like, so Conda came out with this tool where they basically version your binary dependencies as well. So instead of having like a bin-deps file, you would actually have separate binary files that know how to install themselves and have explicit versions. So that in your code, if it's binary and it needs to be shared or it needs to be built, it also has a version, Git version number attached to that build. So it's more reproducible in terms of if you want to switch around versions or see what's happening. What would you feel about that?
I suppose it would solve some of our problems. The thing that I'm not very sure of is whether that's something that needs to permeate the entire ecosystem. So do all library developers have to do that, or can me as an application developer just do that for all the packages that I'm using?
I think it's really effective. You have to like kind of, and that's what they did, was they basically developed their whole system around that idea.
Yeah.
And it basically solved all the problems that you have with scientific, installing scientific packages on Python, because that was just a painful way to do it, but they just did it, and then now it's really easy to install. Software.
Does that mean they just have pre-compiled versions?
No, they just have build scripts, and you say like if you need HDF5, for instance, they have two files where it's a Windows bat file and a make file or something like that, and they basically just run those depending on what versions it is, and it's community maintained all the builds.
How's that different from what you're doing?
It works.
We're doing most of the time.
Because you don't have to use like bin-deps, right? Which is like it's like very explicit because you just use what you normally would use to install software in the computer.
Usually bin-deps is very confusing. There is no kind of good documentation. You have to spend like a lot of time to understand what those markers means, and like how to use them. Because like the example set there help you. Yeah, it's very hard. Like I used it for like the Flan, Redburn, and yeah, like I wrote like 3 or 4 versions until this time like how it actually works, right? And they round up to a few lines actually instead of like going as with examples, a lot of like description, dependencies, which are necessary sometimes.
No, that's definitely fair. It kind of got picked up before it was completely ready, and then everybody used it, and so I can't really experiment with it that much anymore. but I need to get back to like changing it.
So are the Conda scripts open source or are they?
Yeah, so you could we could basically wholesale steal all of their stuff. It's all basically I think we solve.
So maybe you should rewrite Windows using the Conda scripts.
It's worth looking into.
Does Conda support Windows?
Yes, yes. That's like their main goal because it's it's the part of it.
We'll have a contest that they can buy MIT in January to actually sell us on the idea. We said, yeah, we'll look into it. So let's come up again.
I mean, the question is like what you do. Like if you just want to pre-compile your whole own binaries, like that's it. I mean, so you have to have a build script of some form, right? And either you just write them all by hand and then just call out to them, which we can do too. Like it's a one-line call. It's not as straightforward. It's just like you have to have the information on how to build the thing.
Oh yeah,
it has to be somewhere, and somebody has to write it.
I agree, but if you have like hundreds of developers working on this kind of package ecosystem,
it might make sense.
More eyeballs is great, right? Like.
I mean, that's kind of what we're doing with Homebrew, right? We're just using all their build scripts, and then on Windows we were using WinRPM, which kind of uses the OpenSUSE build scripts. So the question is like, somebody's writing all these build scripts, like whose do we use? And I mean, yes, Conda might be the best one, but like it's not necessarily clear cut because other people are doing the exact same thing. So we have to carefully look at what the best option is.
I think WinRPM has worked out pretty well for the Windows builds.
Yeah, WinRPM works very well.
For what's there.
Right, for what's there.
Yeah. But as I said, surprisingly now Mac with Homebrew is actually the worst place.
Yeah, I mean, it's not believable, right?
No, but it is because like Cairo doesn't work on 10.9 and 10.7. It only works on 10.8. We have Cairo local and GTK in global Homebrew. It doesn't work.
The thing about Cairo and Mac is though, it works if you if you just take the Homebrew stuff out.
But it goes well beyond those graphics packages. I mean, so image magic is a dependency for images, and Macs are more common probably among academics and everything. But I would bet we get 5 times more bug reports on the Mac about image magic not working than any other platform. And Ron actually wrote a native OS X image reader wrapper specifically to try to get around that issue. And then it turns out that the native OS X image reader has odd behavior under some circumstances too.
But that definitely did. It seems to have smoothed some things out.
It definitely decreased the rate of bug reports. I mean, like Alan has had an issue getting image magic working on the Mac radio too. So I mean, it's not just these multi-connected, graphics packages and all, right? I mean, this is a relatively modest-sized package, and the Mac is by far the most problematic.
Yeah. At least with the native reader, we have some expectation that code will be there. It should be in the OS from here on out, and it should change relatively slowly. But the dependencies across the board are hard to deal with. Actually, along these lines, what about something like a pip freeze for packages, where I've got some code that works, I love it. It depends on these 6 other packages. I can run a command that just records the commits of all my packages, dumps them in a text file, saves it there, and then 6 months later when I revisit this code, and now 6 things are broken because all these packages have changed, and I need to run this code right now, I can roll back to these commits. Is that something that's possible?
I think that's what bundler is.
Yep.
Virtual env like I think I've had less issues. I mean, I've done a lot more Python than Ruby, but I find virtual env to be much less controversial. I think that all the Python developers I know love virtual env, and it doesn't seem to be controversial at all. And basically, what most people do is you have a requirements.txt file. That is that that you generate it from pip freeze. You type it in requirements.txt, and then whenever you want to install, you just instantiate a new virtual env that's like a fresh Python, fresh Python, and then you basically just you install everything that's in that list, and then that's all of your files in this nice little sandbox. I think one of the issues that like last time when we talked about this a long time ago was just that there are some packages that are such a bear to get installed that you don't necessarily want like separate instances of Cairo in each and every one of your virtual env, whatever the equivalent would be. For me, I feel like that's less of a problem than the dependency hell stuff, and like I'd rather just put up with the extra hard disk space than with the extra time spinning it up.
But it's not just the hard disk space, right? It's about actually compiling. So a lot of the binary dependencies need compilation on your machine. As I said, for Mac, Cairo, for example, it's much easier to compile it yourself than use Ubuntu. So if you're compiling it yourself, then do you want to compile it yourself for every virtual?
Right.
So so where do you store the DLL or the? So that's the other. It's not just about space, about where you get that from.
Well, you can actually leverage that. I've built a system that generates RPMs from the pip install, so that I can mass install that across a large environment, across multiple data centers. So you can actually leverage the work on virtual to create a system level install for the packages. And you can say use update alternatives on Linux, for instance, to do multi-Julia installs as well. I did that with Python as well.
Yeah. That would be interesting.
Sounds complicated.
It was.
Do they all have to have the same architecture?
No. Well, we have to upgrade our OS every year. Anyone else?
Okay. Cool. Just on time. Great to talk.